John Rangel.
And I'm Jorge K.
Dylan Dan.
I'm Carlos Ceballos.
I can't speak.
He lost his voice, so his name's Jesus.
Ah, okay. Any other team members?
No.
Okay.
And this is our robot torpedo. It has 3 Mayfair Marine bilge pump motors with brass propellers.
Yeah, we kind of like made our own camera, and we just filled it with epoxy.
For our frame, we used PVC half-inch because it's cheap and easy to use. We glued it all together with the blue glue and PVC.
And actually, we were using the VEX control system before, but we were having major difficulties with it. So, actually, just recently, we switched the button box to control our motors.
So you have the battery and then the bud box up on the surface.
Yes.
Yeah, and then the umbilical carries the actual power to the individual motors. Okay.
We used
So what design, in the particular parts of the competition, what goals did you guys go after?
Well, we wanted to make our robot as simple as possible because it's our first year.
Okay.
So we didn't want to overdo it with complexity.
So what task did you choose to go after?
Well, this year we're trying to go with looking, and we're going to try to place the Nessie baits too.
Okay.
We put a little PVC up in the front, so we could grab the hoops and place the Nessie baits. And we didn't, like he said, we didn't want to make it too hard, like with a claw or anything, because this is our first year. And we just wanted to go simple. We just wanted the robot to at least swim and have a camera.
We also use it to get past qualifications.
Tell me about the metal straps in there. Metal bars, angles.
Well, the metal bars are actually fiberglass, full-trade fiberglass, and it was easier to mount our motors that way. PVC's round.
But it would have been like kind of difficult to put the motors on PVC. So we just used fiberglass because it was simple.
How do you, why don't you describe your control system a little bit? How do you use your control box there?
We connected all the motors to a tether. And it came up into this button box where each motor was connected to each switch. With these green wires creating current, and these black wires are connecting all of them to the power switch. And this is like the main source. And from the power switch, it comes with the wire to the battery.
We have a fuse to
How many amps on your circuit breaker there?
40.
40.
And we have a electrical diagram.
We were originally gonna add a torpedo to this, but it was too hard for us, so we couldn't do it. And we had to change the schematics a little bit and take off the torpedo.
Maybe had much bull time with it yet?
We tried it once with
Our
the old driving system that he mentioned before with the VEX controllers, but it flooded on us. So then so we tried fixing it, and we couldn't find the problem. So we decided to go with the simpler one.
So basically, there's nothing that needs to be watertight except perhaps for the camera on the robot itself. Everything else is exposed to the water.
These ones that we had to solder,
Yeah.
we had to put epoxy on it and heat shrink.
So we have little chance of leaking.
Well, tell us about the camera.
Camera. We have a camera in here. It's like a small camera, and it also has a mic, but we just covered it too. It has this tether coming through it, tube, and it has a splitter to connect to a TV and one for our live.
What was the camera? Was it like a webcam of some sort, or I mean, what? Pardon?
Okay, and you guys went ahead, you said, poured, what was it, epoxy around the camera? Is that right?
Yeah, we encased it all in epoxy.
And, obviously, you couldn't put epoxy directly onto the lens. How'd you protect the lens and that kind of thing?
We just put the lens like, this is a box.
Yeah.
So this half a box, and we just glued the lens onto the bottom of the box
Okay.
with super glue, and then we put epoxy around it. And then it was like so, it got so hot that
Yeah,
it created like a bubble right here for the
Right.
lens.
So we-
because I guess gas expands, and it just created a bubble. So we had to cut that out, and we had to put Lexan on it, so it doesn't get into the camera.
And how much water time do you have with it so far?
Water time.
Time in the pool, time in, you know.
Well, we've had only 5 minutes.
5 minutes
Okay.
before it flooded.
Now we had to change some stuff on it.
We still have to do a few more things, like connect these, and like we're like done, and then we're gonna test it.
When did you get started? What, how long have you been working on it?
We've been working on it for since 2 months ago. We've been like, at first we were actually overcomplicating ourselves, overcomplicating the robot. So we slowly went to simpler.
That's a lesson well
Yes.
worth learning.
Were you part of the FRC team too, or is that
Yeah.
why?
Now, is the whole team freshmen? Is that why the class of
Yes.
2013?
Yeah.
Okay, so, how many of you have Lego experience prior to? Okay, and, so what you learned this year obviously is gonna be carrying right on through all 4 years.
Yeah, we learned a lot.
So. Okay,
Did you do any mathematical calculations using algebra, trigonometry, calculus, anything like that?
Just with like the voltage and yeah, these for that, and measuring these because we wanted just like 1 foot cube. We didn't want to make it too big or too small.
And what was the biggest technical challenge you guys had?
The Vex controller.
The Vex controller? That's why you just killed it to
Yeah.
that?
Well-
What problems were you having with it?
The wax, it wasn't wax, and since it was getting hot, the wax melted, and so we had to go to this.
Okay. So that you basically had problems waterproofing the receiver?
We had a different motor right here. It's just that the other motor didn't want to work, so we took it off and we just went with one.
Yeah. Our front right now is actually used to be our top. But
Yeah, like we like tipped it over